Let's graph some more rational functions. Alright, same ideas here. X minus 1, that'll show you your x-intercept. Let's find the y-intercept. Vertical asymptote, horizontal asymptote. Alright, so x-intercept occurs at 1, so we get 1, 0. Y-intercept is when x is equal to 0, so you'll get negative 1 over negative 4, so we'll get 1/4, 0, 1/4. Alright, vertical asymptotes occur at the difference of squares, which is x minus 2 and x plus 2. Therefore, we have vertical asymptotes at negative 2 and also positive 2. The horizontal asymptotes occur, oh, look at this. So we have a degree on the numerator that is less than the degree on the denominator. That shows us we get y equals 0. Okay, let's graph it. Small numbers again. If they're small numbers, I'm going to go ahead and go in units of 2 as a distance of 1. So 1, 2, 3, 4. Just like that. Label your graphs. Always label graphs. Okay. 1, 0. Let's do a different color. 1, 0. 0, 1/4. Ooh, 0, 1/4. Small number there. X equals negative 2. Good thing I spaced out my graph. Got those small fractions. Okay, so what is that? X equals negative 2 and x equals positive 2. And then, well, let's do some sign analysis. What's going on over, wait, do we have any? Oh, I didn't draw the horizontal asymptote. Horizontal asymptote. Alright, since the horizontal asymptote is at 0, that really means I should do some sign analysis because that's not giving me any information here. So let's plug in a value like 4. If I plug in 4 minus 1, positive, over 4 squared minus 4, that's positive. So everything at 4 is going to be above the x-axis. So we'll have our graph there. Let's also test a value like negative 4. Negative 4 minus 1, that is negative. Negative 4 squared, 16 minus 4 is positive. So everything here will be negative. So we'll be over here, going towards those asymptotes. And then it looks like, I didn't really draw that very well, but you can see here, let me do it again. You can see there's a horizontal asymptote at the x-axis. Our intercept was at 1, 0, and then we had a y-intercept at 0, 1/4. You can pretty much tell what's going on here. Since we have no more x-intercepts here, we can't cross that plane anymore, which means the graph must be starting down here. You know what? I'm just going to double check. Should I? Is there any rebounds? No, there's no rebounds. Okay, yeah, so the graph does come down, just like that. It goes, ooh, that's a hard turn there. It goes towards that y-intercept and then comes up just like that. There we go. Okay, there we go. There's example 8. Example 9. Let's factor x, let's do x minus 5, x plus 1. And then on the bottom we have x minus 3. X-intercepts occur at 5 and also negative 1. Y-intercepts occur at x is 0, y is, what's that, negative 5. Negative 5 over negative 3, so 5/3. Okay. Alright. Vertical asymptotes, x equals 3, and that's going to be an oblique asymptote. Let's find that. So let's do synthetic this time. 3 is the divisor. We have coefficients of 1. What's that, negative? Negative 4, negative 5. So we bring the 1 down, multiply, add, multiply, and add. Okay, so we have basically x minus 1 minus 8 over x minus 3, but don't forget that just goes to 0. So really your oblique is y equals x minus 1. Alright, I have an x-intercept of 5. I'm just going to go in units of 1 here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, and then we are going to graph. So let's see what we got. 5, 0, different color. 5, 0, negative 1, 0. 0, 5 thirds. 5 thirds is 1 and 2 thirds. And x equals 3. X equals 3. And we have an oblique asymptote at x minus 1. So y-intercept of negative 1. And you, oh, I shouldn't put it as a point, huh? That's going to confuse me as a y-intercept. Oops, I just erased all those values. All right, so at 1, and then it has a slope of 1. Zoom in. Slope of 1. There we go. Okay, all right. It's pretty clear cut how this graph looks. You've only got 1, 2, 3, 4 sections. Your points are actually in this section, so we're going to have our graph in this section. And our point is also in this section, so we'll graph it in this section. Let me undo all that. And let's graph it. Okay, so this graph is coming up towards the vertical asymptote. And please draw better than me. I'm drawing using a stylus and a tablet, so it's not very accurate. I hope you do a better job at home. There we go. That's all. Okay, let's go on. Oh, look at this. So now we are given the graph, and we need to find the actual rational function. So what you want to do is identify all the important parts. One thing to note is it's kind of hard to see on this, but here you have the x-axis. Look at that. At the x-axis, it looks like we have an x-intercept at 6, 0. That's going to be something important to see. As we go through the x-axis, oh, look at that. We had another x-intercept occur here. What is that? Does that say negative 2, 0? Negative 2, 0. Where's the y-axis? Right here. The y-axis, look at that. We have a y-intercept at 0, negative 3. Let's see what else we have. These dotted lines are asymptotes. So we have a horizontal, let's do vertical. I like to do vertical first. Vertical asymptotes at, is that 4? X equals 4. And what's that one? Negative 4. That graph is really blurry. Negative 4. Horizontal asymptote occurs at, is that negative 4? I think that was a y value of negative 4. Okay, so from here, let's go ahead and create an equation out of the information we have. So probably the easiest thing to do is, when we do x-intercepts, we know that that represents the numerator portions. So intercept at 6 and intercept at negative 2 means what we should have is an equation that has x plus 2, that's how we'll get the negative 2, and also an x minus 6, that's what will give us the 6, 0. So we start off with that. Then, on the bottom, that's going to give you the vertical asymptotes, and that occurs at 4 and negative 4. So we'll just say x plus 4 and x minus 4. Okay, so we've taken care of those two pieces of information. The other thing you want to take care of is knowing that you are going through a y-intercept at 0 and negative 3. And then let's go ahead and solve for that. If we say that y equals this, you have to have some kind of a value to be able to kind of modify your function based on going through this point here. So if y is negative 3, then if x is 0, then we'll get a times 2 times negative 6 over 4 times a negative 4. Let's see what we get there. That is the same thing as negative 3 equals negative 12 over negative 16a, so those are all positives, right? And then when we solve for a, so a is basically a value of -4. Okay, so then we're going to write that into our equation. Basically, now what we have is y equals -4 times x plus 2 times x minus 6 all over x plus 4 times x minus 4. If we verify, just make sure that works with the horizontal asymptote, you do see that the factors, they multiply together. You're going to basically get x squared over x squared. So what's important in getting that horizontal asymptote is that they're the coefficients of your leading terms. And we can see, oh, that's why we actually had that -4 there. So it all works out. That's going to be our equation of our rational function there. Okay? All right, let's stop there, and then I'll make another video for 4.6. Oops, that's not how I stop it. Hold on. How do I stop this? Ah, sorry. Let me just stop it this way. Can I just push this?